Very good evening, Lakshmi. How are you? Very good evening, sir. Okay, Lakshmi. I'm fine. How about you? Let's wait for 2 minutes more, then we are going to start with the class, okay? Very good evening, Harika. How are you? Okay, then let's just continue with the class. First of all, wishing you a very good evening, and it's going to be the eighth session of this chapter. Okay, so let's just start with today's class. Let me just give you a quick brief about the previous class. So in the previous class, the last topic which we covered there is the Kolbe's electrolysis, right? We just start with this point there, and there we discuss about only two type of reaction, if you remember. That is a reaction number one, electrophilic substitution reaction. There we discuss about bromination, that if I'm using concentrated HNO3 or diluted one, then how we are getting different kind of product. And then bromination, the bromine water we are using, or we are using bromine like with non-polar solvent. So we are end up with a different kind of product there. So this thing we already covered there. And the second one is the Kolbe's reaction there. So what is the meaning of the Kolbe's reaction? In the Kolbe's reaction, you're just starting with the phenol. Let me just give you a quick brief. So we are just starting with the normal phenol there, okay? And in this case, first of all, you are going to add some NaOH there. So what is happening after the addition of NaOH? That there is a formation of the phenoxide ion. This is a Na positive and the O negative is there. So phenoxide ion. The next step is going to be the CO2 or some acid there. So what is happening after the addition of the CO2 or this HCl there? We are just simply getting that is a salicylic acid there. Simply that this is the case and this is a OH or the COH group connected here. So this part we already covered, or you can say the last topic of the previous class is this reaction, Kolbe's reaction there. Okay, so let's continue with the next one. That is the Riemann, you can say Riemer-Tiemann reaction or Riemer-Tiemann, whatever you like, you can use. Okay, so the this is all for the reaction. Now let's start with the third reaction in the reaction of the phenol. That is the Riemann-Tiemann reaction there. Okay, so let's just start. Like in this case, what we are using and what we are getting basically. Okay. So again, like every reaction, we are going to first discuss about the reagent and then reactant and then product as well, and even mechanism as well. So this is the name. It's a Riemann and Tiemann reaction. Is it so? Okay, this is the name of the reaction. So now let's start that what about the reaction there? Definitely the reaction is what for phenol. So we are just starting with the phenol there. And in this case, what which kind of reagent we are using? So like the previous one, we are going to use NaOH in this case because the step number one ditto, like there's a formation of phenoxide ion first of all. And this side, I'm using extra point that is CHCl3. What is the common name for this? CHCl3. Okay, till then you have to answer the question. This is the reason number one, and the reason number two is what? We are going to use some acid like the previous one. What is the purpose of this? This is nothing. Be noted when this is written be like this, so it's nothing. It is going to be the hydrolysis only. Okay, hydrolysis, simple represent the hydrolysis step there. Okay, so what we are getting as a product in this case, the OH will remain same. Okay, the OH will remain same. So it's like the Kolbe's reaction, but there's a small difference between both the cases. This time we are end up with the CHO. Okay, yes, in this case we are getting aldehyde as a functional group. So what is the name? Like the previous one is the salicylic acid. Okay, so what is it? It's a salicylaldehyde there. So what is it? The common name is what? It's a salicylaldehyde. Okay, salicylaldehyde. So like as we already covered, what is the use of this NaOH there? Just to increase the rate of a reaction, just to generate the phenoxide in here. Okay, so this is a Riemann-Tiemann reaction there. Now, okay, so let's discuss about the second point. Like what are with the the thing written on this arrow? So these are the reagents. So reagent is what? Okay, yes. What is the name of this? Chloroform. Yes, very good, Lakshmi. It's a chloroform simply, right? So chloroform, NaOH, and this question asks so many time in the PYQs, like what we are going to use in this reaction. If you want to form a salicylaldehyde, it's really much important. Okay. Now let's start with the mechanism. So for this one, the mechanism little bit different. Okay, why I just said little bit different, because now in today's class we are going to discuss about a new thing. Okay, so wait, we will cover that part as well. First of all, let's just talk about the mechanism. So let's see that again. How about the mechanism in this case? Let me just write the statement. Okay, then we're going to discover the theory part as well. So the step number one. So in this case, what is the step number one? Step number is one is what? Formation of carbon intermediate. As I already told you, we are going to discuss about a new kind of intermediate. So formation of carbon intermediate. Okay, but no, we don't know this intermediate. Only know carbocation, carbon, and a free radical. But what is this carbon intermediate? We will cover. Wait for a while. Okay. Second step, that is a step number two. After the generation of this carbon is an intermediate, now there is a formation of benzyl chloride. Okay, benzyl chloride. I hope you already know what is the meaning of benzyl, what is the meaning of benzyl, and what is the meaning of benzo. Okay, so it's a formation of benzyl chloride. I will tell you what is this if you don't know about this. It's a benzyl chloride intermediate. Or the step number three is that hydrolysis of the benzyl chloride. Hydrolysis of benzyl chloride. Okay. So the same thing, undergo hydrolysis there. Now some point, first of all, what is the meaning of this benzyl? Okay. Anyone do you know the meaning of this word benzyl? Garin Patula. Yes, please. Do you know the meaning of this word benzyl? Okay, Mani, you are technically right. I will give you some kind of, like question type. Okay, so just try to answer the question. Okay, so what are the name of these things? Oh, sorry. CH2, right. So listen my point. Do you know when we are going to use this word benzyl? Benzyl. When the benzene connected with the carbon and carbon is going to connect with the two hydrogen. See this, in this case we are having two hydrogen. And what is the name for this compound? Like the common name for this compound is what? That benzyl chloride. You know, it's a benzyl chloride. Okay, cool then. How about the second one? Look at this, that if let's suppose the ring which is connected with the phenyl, sorry, the carbon which is connected with the phenyl, sorry, benzene, and if it is connected with only one hydrogen, so now we are going to use That is, it's going to be the benzyl. You know the name for this compound? Like common name here. So what is the name for this compound? It's a benzaldehyde, you know? It's a benzyl aldehyde. So like there's a tie between aldehyde and then benzyl. That's why we're using this. So this is a benzyl, okay? All we are going to use. And in this case, that if the carbon is connected with zero hydrogen, you can say. So what is it become? It become benzo. So this is how benzyl, benzyl, and benzo. Like as you know, the name for this compound, it's nothing. It's like benzoic acid. Okay, so that's it. It's important here. Like here the benzyl, here the benzyl, or here the like benzo. Okay, so it means that if I'm using this word benzyl chloride, so be noted, it means that you will be having some kind of benzene. This is connected with the carbon, and that carbon has only one hydrogen. So it's totally clear the point. Like chloride means there's a two chlorine have to be connected. This is how you can identify the number of carbon and hydrogen even as well. Okay, that's it. Yes, very good, Mani. Okay, so I hope my point is clear for everyone. So now let's just back again and let's back to the reaction. Now the second point, you know, what is this carbon? What is this carbon? So let's understand what is carbon. Okay, so right now we know that first of all this is a hydrogen, and this is a hydrogen, and this is hydrogen. Okay, everyone, you know the methane molecule, right? And in this case, what is going to happen now? Hydrogen will like, I'm taking electron. So the carbon got the positive charge like this. Okay, so better to write that six electron, right? One, two, three. Let's just read. Let's suppose this is how the homolytic cleavage kind of thing, one carbon, homolytic cleavage kind of thing, and there one electron there. So let me just erase this. Okay, so it means this kind of intermediate is known as carbon, is known as carbon. You can say that carbon has a lone pair kind of thing. Okay, lone pair kind of thing. Now, next question. You know the what is the misconception here? Ma'am, you just discuss or we just discuss about this. There's a lone pair kind of thing. Now, my next question to you, according to you, it's electron rich species or it's electron deficient species? First answer this question. This is carbon, okay? This is carbon. Is this electron rich species or electron deficient species? Hint, count the number of carbon. What is the meaning of EEL for? Electron rich. Okay, very good. So, now, next question, please. Carbon radical is electron rich or deficient? Batula? Because extra electron, maybe it is going to donate. So it's rich or deficient? Rich? Oh, what are you doing? We discussed so many time that in this case there is a one, 2, 3, 4, 5, and 7 electron total. So 8 electron we are going to require here, or like we are requiring here, Niharika. So we discussed this thing so many time. Carbon radical or the carbocation both are the electron deficient species. Okay, something strike in your mind? Now for the same carbon, let's count the total number of electron there. So if you to count 1, 2, 3, 4, 5, and 6. So in this case, you are having only 6 electron. Isn't it like the carbocation? This one has a tendency to accept the electron. It's electron deficient species. So be noted like what is the problem? We be like okay, there's a two electron present. Like most of the time it's written be like this. Okay, there's a two kind of lone pair or okay, it's electron rich species. But be noted, it's not rich. It's deficient. It's a six electron species. Okay, and we want eight electron. Okay, Batula Niharika. So be noted. Now the next question. Okay, so let me just erase this. So now it's electron deficient, okay? Carbon is what? Electron deficient. Second point, 6 electron spaces. Okay, cool then. Now, okay, this is carbon done. Now we have to classify this carbon into the two part. Okay, two part. That one is singlet and one is triplet. Okay, so now we are going to apply a little bit concept of the atomic structure. So now answer this question please. If you know, if you don't know, don't worry, I will explain. That spin multiplicity formula. Spin multiplicity formula. Or how to identify the spin multiplicity of electron. Yes, please. Spin multiplicity. This is my question. Okay, wait, I will give kind of hint, but I want to ask here simply. Okay, for example, okay, find out the spin. You know the spin quantum number S. Okay, so or you can say ms. So what is the value for the spin quantum number? Yes, you're right. Yes, please. What is the value for the spin here? Or the spin quantum number, what is the value? Come on, it's a very basic question of the atomic structure. Hmm? Okay, so let me just count quickly. So you know the half and half? Okay. So half for this, plus half for this, plus half for this, and a plus half for this. Okay, so total it's become 3 multiplied with half, and we're getting 3 by 2. So this is spin. It's a spin formula only. Now, let's talk about the spin multiplicity there. So what is the formula for spin multiplicity? Okay, this is the formula 2s plus 1. What does s here? This is s. You know, we just discussed about the spin. Spin is this there. So you can say 2 multiply with 3 divided by 2 plus 1, 2 cancel out, and we're getting 4. So what is it? It's a quadrate. Okay, you know the meaning of the fourth. It's going to be the quadrate. Okay, so like if 2 there, so doublet. If 3 there, triplet. If 1 is there, singlet. Or if like 4, quartet. 5 is there, so it's become pentate. Okay, I hope you're getting my point. Now, in this case, this carbon has a p orbit, you know, like let me just write the configuration for a carbon. So it's going to be the 1s2, 2s2, and 2p2, right? So you can say that in this case, the carbon has a p orbit. And let me just write the p orbit, how it's look like 1 and 2 electron. Okay, so definitely here p electron is vacant. So let me wait, represent in form of orbit there. So in this case we are having a choice. Okay, so although like you know the above rule said, Hunt's rule said, or like Pauli's rule said that every box contain at least single electron. Okay, you can use any orbit, but Ula, okay, it's not like d orbit. But I want to connect the topic because we discuss about this thing in atomic structure and they were containing the d orbit. You can take any orbit. Okay, s you can take, p you can take, anything you can take. My point is what, that spin plus half if the single electron, doublet is there, so my plus and minus is going to cancel out and we're going to get the zero there. Okay, Batula, so this is my point. So now let's just back here what I want to explain to you. So in this case, the carbon has a 2 electron and there is a 2 orbit vacant, you can say. Okay, basically if you're observing, these 2 electron orbit is participating in the valency there. So according to this one, that the condition number one, maybe this orbit has a single electron or maybe this orbit has a single electron. This is the case number one. Or let me just write the on the next slide. That is what is singlet carbon. What is the singlet carbon? When you are having a carbon, okay, hydrogen is a single thing. Okay, now in this case, look at this. Singlet means that is maybe both the electron present in a same orbit. Condition number one, because two orbit, two electrons. So maybe both combine or maybe both are single there. So in this case, if I want to calculate the spin quantum number, so what we are getting, that is, the down spin or up spin, one is plus half, one is minus half. So we are getting total zero is the answer here. Right? Zero is the answer here. So then how about the spin multiplicity? It is going to be the 2s plus 1 and it's become 2 multiplied with 0 plus 1 and we are getting 1. I hope this point is clear. What is singlet carbon? That when both the electron present only one orbit. Condition number one, singlet carbon. Let's talk about the second type, that is a triplet carbon. So what is the meaning of this word triplet carbon? Look at this carbon. Okay, so this time maybe both the electron is single and single there. Okay, like this. So again, what is the value for s? If you have to count here, that plus half become 1 there. The plus half become plus half, it's become 1 only. And now let's identify the spin multiplicity. So it's become 2s plus 1. 2 multiplied with 1 plus 1, it's become 3 there. So I hope this point is clear that it's 1 and it's a 2 there. Hence the name become singlet and triplet carbon. Now, answer this general question between triplet and singlet carbon, which one is more stable according to you? Think about it. Very good, Srividhan. Yes, please. I will give a choice. You're having singlet carbon or triplet carbon. So, according to you, which one is more stable? Just a very general question. Apply your common sense. Try to answer the question. Triplet or singlet? Yes, of course, triplet. Okay, why? Because we know that, look at this, if in both the electron present in the same orbit, so repulsion start. Hindrance, repulsion, so many things is there. Okay, but on the other hand, look at this, that both are single and single. So good, triplet is more stable. So first of all, like what is carbon? A 6 electron species, electron deficient species. It's a classified into the two parts, singlet and triplet. And if we are talking about the stability, so stability wise, triplet is more stable over the singlet one. Okay, now the most commonly asked question from this topic, if there is a carbon, okay, and it is connected with any species, which one has a lone pair, let's say, the halogen is the favorite one. So look at this, it's a halogen. So now same question, that according to you, triplet is going to be the stable one or the triplet, sorry, triplet or singlet, which carbon you are going to prefer now? I'm repeating my question. Listen, that we discuss between singlet and triplet. Triplet is generally stable, but general thing is not really exist in chemistry. As exception is always there. So, if let's suppose this is a carbon and it is connected with something has a lone pair. So, according to you, now which one is the more preferable one, like triplet or singlet? This is the second question. Yes, of course, singlet. Okay. So in this case, what is happening? Let's suppose that both electron is present. Halogen will be like, here I'm having a lone pair. So carbon will be like, not an issue. Let's do what? Let's combine the electron, and now I'm having vacant orbit, and then you can transfer the electron to me. So what is it? It's kind of resonance kind of thing. So see this, that if something has a lone pair connected with the carbon, so generally triplet is more stable, but this is the only case where singlet is much more stable or the triplet carbon. It's really important. So means, which kind of question ask from this? Since we're discussing about the Riemer-Tiemann reaction there, so question ask in Riemer-Tiemann reaction, which kind of carbon we are end up? As we discuss benzyl chloride, it means carbon is combining with two chlorine. So it's really really important that in Riemann-Tiemann reaction, the carbon which we are getting is singlet, not the triplet. Be noted, singlet. Why? The chlorine has a lone pair. Okay, so I hope this carbon intermediate is clear for everyone. We are having still two intermediate more, like one is benzene and one is nitrine. So nitrine one we are going to discuss in amine part, and the benzene one, carboxylic acid. Okay, so this is all for the like general statement base. Formation of carbon, then formation of benzyl chloride, and the last one is the like hydrolysis part here. Now let's start with the typical mechanism. Okay, like how the mechanism look like. So let's continue with the mechanism part. So as we discussed, the step number one is what? Generation of carbon. Okay, step number one is what? Generation of carbon. So who is going to generate the carbon? Definitely, the carbon is generated by the CHCl3, it means chloroform there. Okay, then cool. So this is a hydrogen, and you can say three chlorine is connected. If you're not getting, let me just quickly give you a brief. See, we are using chloroform and NaOH. So CHCl3 is there. Okay, and NaOH is there. Okay, so I hope everyone, NaOH is a very good base. So what? Obviously, it is going to abstract the hydrogen. So this abstract the hydrogen from there. Okay, so you know how the bond break here, like hydrogen, that is OH. We want H positive, so that's why the carbon got the negative charge. Okay, this is just for understanding purpose only. Okay, obviously we are not going to show the charges be like this. Actually, how the step look like this. So means carbon negative charge, and a chlorine and a chlorine and a chlorine, and like there typically water molecule evolved out. Okay, so now negative charge, the negative charge is being like a simple kind of driving force. So this is attacking here, and chlorine leave the molecule. Okay, chlorine leave the molecule. Then what we are getting, that we are just left with the two chlorine, and there's a two electron there. So what is this typical thing? This is carbon. Now the step number one is complete. We are getting carbon there. Okay, so our okay, so should I call this electrophile or a nucleophile? So what is it? Electrophile or a nucleophile? Yes, please. Carbon is ready, but it's an electrophile or a nucleophile. This is my question. Recall, it's electron deficient species. It means it's being like a electrophile. Okay then, so it's a electrophile simply. This is being like electrophile. Okay, then electrophile is ready. So how about the step number two? Step number two is like ditto like the previous one. So basically what is happening? That you will be having a phenol since we are using NaOH already there. So if you are using NaOH, we are getting sodium phenoxide. Okay, this is just a counter ion only. So what is happening? O negative attack here, and this be like this. So this is the ditto, the previous step we already covered, right? So it's a negative charge generated, and it's a double bond like this. And now carbon is ready. Okay, so this is our carbon. It's a chlorine, it's a chlorine. So this negative charge attack on the carbon. Why? Because it is behaving like a nucleophile, okay? It's behaving like a nucleophile, and it is being like a electrophile. So every time nucleophile is going to attack on a electrophile, not electrophile. Because sometimes, this is very important mechanism for board exam as well. Most commonly asked question. So what is the problem with the student? They used to be like, because it's look like carbon has a lone pair, but no, it's not like that. Okay, yellow one is the wrong. So remove. Next, then there is a formation of double bond, and like this carbon Cl and Cl there. Okay, so okay, there is a carbon connected here, but if you have to observe one and two, three, only three bond there. So carbon has a positive charge. So this is a hydrogen, right? So what is happening here? That like the previous one, hydrogen attack here, this bond open up, and this carbon attack on this hydrogen like this. So what we are getting, so this bond open up, and double bond, and this hydrogen connected here. So we just discuss this point, just discuss that what is it? It's a that benzyl, that benzyl chloride. Let me just back again. I'll read the step number two. That the formation of benzyl chloride. Okay, so that benzyl chloride intermediate is ready now. So it's this is that benzyl chloride. Okay, and the last step is what? Hydrolysis. Okay, for this one, the mechanism is not really important, ma'am, how to go with the hydrolysis. So when you have to undergo the hydrolysis, what we are getting, that phenol is back, and this is a COOH is there. So this is ready, which we want, that is salicylaldehyde. Okay, the salicylaldehyde is ready now. So any problem with the mechanism, with the reaction, please let me know. I can explain one more time. Please quickly confirm. So two reaction, that one is this, and the second one is what? Okay. Okay, this step. This one I'm writing on the next slide, okay? Maybe you're like, ma'am, how you are doing this, okay? So this step I'm explaining how we end up with this and that, okay? So look at this. So what is really going to happen in this case? That O negative, right? It's a carbon, chlorine, and hydrogen. Since we're using a base, so it's this OH attack here, this chlorine loop. Okay. Similarly, like it is followed by two time, like the same step. So what is really happening then? That we are getting it's a O negative, okay, carbon connected with the 2OH like this. Okay. And I hope you already know that is on a same carbon, two conjugated OH group is never ever stable. So they quickly form the water molecule, release then, and then we are getting simply that it's a benzaldehyde. Okay, like this. So aldehyde we are end up then, and then this next step again that hydrolysis part. So I hope hydrolysis you know very well. H positive you're using, it's a negative, it's a positive, both combine and we're getting H is there. Okay, so this is the extra step. If you want to add, you can add it. Okay, otherwise it's okay if you just simply write okay hydrolysis. Okay, just go for that, baby. So both are important. That's it. This is all for the mechanism of this Riemann-Tiemann reaction. Okay, third, that's it. This is all the reaction. Now let's back toward the fourth part, reaction with zinc. Okay, so this is really important reaction for mechanism part. How the mechanism ask? You are having some phenol, how to end up with the benzene. So this is again important reaction with zinc dust. So as the name suggests, reaction with zinc dust, we are just using a very small pinch of the zinc. Okay, so reaction with zinc dust. So mechanism is not important here. Thank God. Okay, we are not going to discuss about the mechanism here. So how about the reaction with the zinc dust? Wait, let me just check any point. Okay, that's zinc dust is the next one. Some question is there. Okay, we are going to solve that question later. Wait for a while. So this is simple. We are having a phenol. So it's simply combined with zinc and heat it and we're getting benzene. It's important for the conversion point. Okay. That's it. Next. O plus. Okay, so can you just tell me, is this is a redox reaction? My question is what? Is this is a redox reaction? Okay, I will. Okay, wait, Lakshmi. Yes. Okay. The next type of question asked from this reaction, do you know what? That, oh, sorry. Is this is a redox reaction or not? So yes, it's a redox reaction. From there to there, what is happening? Loss of oxygen. So what is it? Reduction. So it's a reduction part. Okay. And zinc 0 to 2 positive. So what is it? Oxidation part. So yes, it's a redox reaction. Okay, so let's just back again. Okay, my bad. I have to start with this step again. Okay, so listen actually what is happening. You're having this, okay, Lakshmi. So if you're adding NaOH molecule one time, NaOH, NaOH we're adding. So let's just back here. Where's the second slide? Okay, yes, this here. So look at this. This is a OH ion. And what is happening there? As the OH ion attack here, look at this. It's attacking here and the chlorine molecule leave. So what we are end up with? We are end up that this is a phenoxide and same thing and a carbon connected with one OH group and then chlorine and then hydrogen. Still we are just left with one more chlorine. Okay, Lakshmi. So again what is happening? OH group come attack here and this molecule leave. So this is how we are getting this thing from there to there if I'm using 2 mole of NaOH. Okay, is this point clear? First let me know. Previous, I'm sorry then. Which one? Let me just take some number. Okay, like step number A, step number B, or step number C. Which one? And before this, we discuss about the carbon. Pink one. Okay. Okay, okay, okay. It's a double bond. Okay. So it's a carbon, chlorine, chlorine. Carbon has a positive charge. Okay. So this is a hydrogen. So basically what is happening? This is how the bond break. Okay, this bond open up. So we can say if this is happening, simple, there's a negative charge generated. Okay, there's a double bond. Okay, once we're getting this, H positive is already free now, free you can say. Okay, so in this case, what is happening? This H positive is entering. So carbon will like, why not you can combine with me? So this is how the carbon attack on a hydrogen, or this is how the hydrogen combine with the carbon. Is this point clear? Lakshmi. Okay, so first of all, that benzene restored again, then hydrogen is free now, and that hydrogen is taken by the carbon. Okay, Lakshmi. Okay, you are saying both are the positive and positive there. Okay, wait, wait. Okay, I'm sorry. I have to put the negative charge here, right? That's the mistake. Okay, wait. I will explain now. So this is a carbon, chlorine. Chlorine is there, okay? So you can say there is a two electron already present. Okay, and this is vacant orbit. Let's say. Okay, we are considering it's a singlet carbon. Okay, so it's a phenyl. That is the only problem. I'm sorry. Negative charge have to be there. So it's connected here like this. So when it's connected here, look at this. It's a carbon combined with this benzene ring. Okay. So this is chlorine and this is chlorine, and there's a two extra electron as well. Okay. Let's count the total number of electron, Lakshmi. So let's count one, two, 3, 4, 5, 6, 7, and 8. Right? 8 electron is there. And if we are counting the number of electron for carbon only, just carbon only. So 1 electron, 2 electron, 3 electron, 4 electron, and 5 electron. So when the carbon has 5 electron. So you know carbon 4 electron, 0, carbon 3 electron, positive charge, carbon 5 electron, negative charge. Okay, so that's why now carbon has a negative charge. Okay, so I hope it's clear now. Okay, I'm sorry I have to connect that. Where is the slide? Hmm. Sorry, sorry. Okay, negative. So the basic is clear, like how there is a negative charge generated. Okay, Lakshmi. I hope it's clear now. Please confirm. Is this clear or not? Shall I repeat one more time? Lakshmi. Okay then. Okay, so this is all for the reaction. Done with this. Zinc dust one we're discussing, right? Okay, so zinc dust part is now sorted. Now let's see the next. How about the next? I have to check weight. So this part is done. Next one is the oxidation here. So like oxidation reaction there, okay? Then reaction with phenol, okay? Oxidation reaction. So now let's just talk about the oxidation reaction as well. So like since we are discussing about oxidation reaction, so which kind of oxidizing we are using? That most important one. It's oxidation there, okay? Oxidation of phenol. So first of all, let's write the reagent which we are using, okay? Because reagent is the very much important part. So which kind of reagent we are using? Reagent is the that Na2Cr2O7. It's like K2Cr2O7. If you remember the D block element that we discussed about, that Na2Cr2O7 is what? It's a soluble in nature. That's why we are going to use this as an organic chemistry. And K2Cr2O7 is insoluble in nature, and that one we are preferring for titration part. We discussed this thing already in a D block element, if you remember. If you don't know, then check it for that. Okay, anyway. Or H2SO4 is there. So what we are getting basically that if you are having this phenol, Okay, if you have to start with the phenol, and if you're using this reagent Na2Cr2O7, like these are the memory type of questions, so you have to just remember the reaction. So it's a little bit kind of important. Okay, so this is we are getting that both combine, and that both position the oxygen have to be there. So what is the name for this compound there? It's a benzo. Okay, it's a benzoquinone. Quinone. Quinone. Okay, so quinone is there, benzoquinone. So sometimes the name is also important because it's a different name, benzoquinone. That when in the kind of double bond and can combine with two more oxygen, benzoquinone. Okay, so that's it. This is all for the oxidation part. Now, one more point, that if you to put the phenol in the open air, if you to put the phenol into the open air, it's a kind of not for you. So if you to put in the open air, let me just write open air. So what we are end up there, that instead of getting oxidizing product, we are getting a mixture of quinones. Okay, it means we're get end up with a different kind of quinone, substituted or not. So the mixture of quinone we are getting. Okay, it's a not. Let me just write. It's extra point for you. Not. So mixture of quinone we're getting, and just because of this, we are end up with a dark pink color, dark pink color compound. So if you want to check it whether we are getting a phenol or not, just put in a air, open air, and we are getting that is a dark pink color up here. Okay, so it's a kind of test as well, you can say. The last one is what? Identification of phenol. So it's really important. Idoform test, Tollon reason. Same like for the phenol, that one of the famous test is there. That what is the name for the test? Reaction with phenol. If you want to check it, the presence of phenol, phenol and alcohol are a different functional group. So yes, only phenol give the test positive with this FeCl there. Okay, so we are just discussing about the reaction with FeCl3. And for different kind of phenol, we are under with a different kind of color as well. Okay, important is what the complex is important. So in this case, what is happening? If you will be having a phenol, how the question frame from this topic, there is some compound A, when it is reacted with FeCl, there is a complex formation. This is the color of the complex. So means question just simply want to highlight that yes, you have to consider it is going to be the phenol. Okay, so it's a phenol, and we are using FeCl3. As you already know, in this case, the iron is present in +3 oxidation state. Okay, so basically what is happening? See, this is my, okay, this is the acidic hydrogen, negative. Wait, it's a polar bond, right? Partial negative and partial positive. So there's a 3 chlorine. If you're observing, there's a 3 chlorine. So chlorine combined with HCl. So what is happening? 3 HCl molecule release. 3 HCl molecule release, and you're going to use this as a 3 as well. So minus 3 HCl release there. And iron is combined with a different kind of O there. So there is a complex formation. This is Fe. So it's a phenoxide ion because the hydrogen is extracted by the chlorine. So this is oxygen. This is oxygen. It's a kind of complex formation with the iron. Okay, like this. And this is how the complex formation take place. It's coordination complex. Okay, because iron present in +3, this one has a vacant d orbit, oxygen is being like a ligand here, so it's a kind of complex of iron molecule. Okay, so let me just use this now. And how about the color there? Color is like not fixed because for a different kind of phenol there is a different kind of color is there, but for this typical the purple color appear. Okay, it's a purple color complex. So it's a purple color complex. This is how the reaction with FeCl. Intermolecular bonding. Yeah, you're right. Benzoquin, hydroquinone are the same. Benzoquinone, phenoquinone, and that is a quinhydrone. Okay, so you can say quinhydrone is not quinone. Okay, in place of hydrone, you have to use quinone because hydrone is what I will explain. Let's suppose this is OH. So this one is that you are mentioning, hydroquinone one. But if this is the formation there, so it's a benzoquinone, it's a quinone as well. And one more you are mentioned there. That is phenoquinone also, right? Okay, all are the same, Shiva, you're right. Okay, so that's it. This is all for the reaction. Now, one more important point that I aspirin. So let's discuss about the preparation of aspirin. Again, this is a potential question from this topic. Okay, like actually, wait. This is a kind of subtopic. After the completion of the phenol part, now the next topic is going to be the use of phenol, like where we're going to use the phenol. And in the use of the phenol, the first application is the medicinal chemistry. Okay, so you can say that is a medicinal chemistry. And this medicinal chemistry part, that the very much important kind of use is what? That aspirin. Anyone, do you know the use of aspirin in our day-to-day life? Yes, please. Aspirin. Okay, let me just write the name of the drug. That is aspirin. Although you are not doctor, but still, at least you know the use of common drug, right? Chloramphenicol, quinone, aspirin, zinc cleaner. Although if you're using 1% phenol, so that is well very good antiseptic as well, right? Sorry, 4% is the antiseptic, 1% is the 1% is antiseptic, 4% is disinfectant. You're right. Painkiller. Okay, so you if you are having a headache or anything, although this is a anti-fever drug, okay, the main use, but that is you can use for the headache as well. Okay, or wait, painkiller is the good point, and famous for, let's suppose, okay, sometime let's suppose a person has a heart attack like this. Okay, so what is happening in the very first, like the pain is just start, okay? So you can give the aspirin there. So it increase that heart attack time, okay? That the you can say the vein blockage time increasing by consuming the aspirin. So it's a very good use as well. So for heart attack as well. And one more, fever. Okay, so the common use of this. Now, the important is what? How to form the aspirin. Okay, like how to form the aspirin there. Okay, so everyone, you remember the call-based electrolysis which we discussed in the previous class, if you remember. So let me just quickly write the step there. So basically, you are having a kind of phenol, and then we are using NaOH. In the step number two, we are using CO2 and some H positive ion, and we are end up with this. Okay, like this. Okay, so what is it? It's a salicylic. We already covered this in the previous class. Sorry, salicylic acid. Okay, now basically in this case we are going to follow the esterification. Do you know what is this esterification? Ma'am, Dolo and paracetamol. Uh, See, aspirin is a different drug, okay, and paracetamol is a different drug. Actually, see, every drug has a different salt. Even one drug not have any common salt, but every fever drug most of the time contain anti-fever kind of compound. Okay, so although the medicinal chemistry is not in your syllabus right now, okay, otherwise we will be having a very good idea like this. Okay, paracetamol is this para, and where's the aspirin is the. No, see, I guess Batula is asking about that is in Dolo or paracetamol, aspirin is there or not. Okay, so like for example, let me just give you example. If let's suppose you are having acidity, you can use ranitidine as well. You can use Aciloc as well. Okay, even you can use cimetidine as well. Okay, there's a different kind of salt is there. Okay, same like that you can use aspirin, even you can use paracetamol. Okay, so I'm not saying here that both are the same molecule. I want to highlight to you that the salt is different, but function is same. Okay, Shiva, I hope you're getting my point. Okay, Batula, I hope this is also clear for you. Or any common drug. Let's suppose you are having a headache. Okay, so the common one is what? I don't know right now which one is the common one, but I guess headache drug. No, Sarutinol. Saridon, okay? And okay, anyway, I hope you're getting my point. Okay, so that's it. Oh, yeah. Thank you so much for this. Okay, so we're using some ester there, okay? So basically what is happening, in this case, we're using anhydride. Okay, don't say ma'am in ester, we're using SL. Okay, listen my point. I just want to explain here that the step is be like esterification. Okay, don't say ma'am, like this is not written in a book. So let me just erase this. So what we are using here, that is any anhydride there. So let me just write the structure. I hope you know what is it. Acetic anhydride. Okay, can you just tell me the name for this? What is the name for this compound? Volin spray. Oh yeah, you that is for different kind of purpose. Volinin. That I guess for knee joint pain as well, headache as well, back pain as well. Even we are using paracetamol for the headache as well, for body ache as well. You know, we are the cheap doctor in our home. Just please answer this. What is the name for this given compound? Acetic anhydride, phenolic anhydride. Okay, both are right, although but one is common name. Very good. Okay. Yeah. So in this case, oh, you're justifying your point. I'm sorry for that then. I was not able to understand there. So what is it? It's acetic anhydride or it's ethanoic anhydride as well, okay? So it's a acetic. I hope you know why the name is acetic because this group is present there, okay? And why the name is anhydride? Because this is present here. So it's a anhydride. Okay, anyway, so what will be the next step? For this one, I'm moving to the next slide. If you're using some ROH, okay, and some RCOR is there, okay, like this. Okay, so what is happening there? Just try to understand the mechanism. Just our mechanism is important. This attack here, this bond open up, this back here, and this leave the molecule. Okay, so in short, in this case, what we are end up that R, O combined with this COR is there. Okay, so directly, what is it? It's ester formation. That's what the name for the reaction is what? Esterification. So same we are going to follow here that it's a acetic anhydride. So this is a OH group. It is combined. Okay. So this will remain same that acid is not going to attack O, CO and CH3. So this is the thing that which we really want. It's a aspirin. Okay, so like preparation is a little bit important. Let me just check. Where's the slide? Yes. Okay, so this is all for the aspirin. Now let's see the okay, so let me just write the uses quickly. So one uses this aspirin one and the second use I'm just writing the uses only. Second use is what? Use in solvent paint industry, okay? If you really like painting, I hope you know the use of this. If let's suppose you're not having oil or the tarpon oil in your home, so you can use this as a substitute as well. Very good thing. Next is used as a solvent. Solvent in manufacture of formaldehyde. How it is possible? Don't worry, we are going to discuss about in the upcoming classes. Formaldehyde. Okay, now let's discuss about ethanol specially, okay? Because ethanol has a separate kind of uses. Okay, so now right now we are just considering only the ethanol, separate ethanol. Okay, so because there is some famous topic in this case, first of all, we are going to discuss about ethanol. And in ethanol part, we are going to discuss about three things. First of all, preparation. Okay, second of what is the property and then uses. Preparation, property, and uses part. So let's talk about the preparation part here. Preparation is important, although it's not really important here, but it's a really important topic of the biochemistry. So you have to start with the sucrose. So sucrose is what? C12H22 and O11. It's a sucrose plus water. If you're using sucrose plus water and if you're using invertase is enzyme, enzyme is important. Enzyme is important. I'm repeating again. So we are end up with the glucose and the fructose as well. Okay, maybe it's look difficult right now, but don't worry when we're discussing about the thing in a biochemistry. So it is going to be the easy one. Okay, the very easy reaction is this glucose and the fructose one. Glucose and the fructose. If you remember the chemical kinetics, what is it? It's an inversion of cane sugar. Okay, or that basically it's a fermentation. Okay, you know the fermentation that we used to form the alcohol generally from the fermentation reaction. Okay, fermentation of the rice, fermentation of the barley seed. Okay, this is how. So that's it. One more. This one, okay, glucose we're using further. C6H12 and O6. And in this case, I'm using gymase. Both enzyme is important. Gymase as well and then invertase as well. And then we are getting this ethanol, the thing which we want. I hope you know in the lower classes that due to the excessive exercise there is a lactic acid formation in our body. Okay, just because of that we are feeling the pain and fatigue in our muscles. So it's, you can say, it is a kind of incomplete oxidation. So same kind of thing, during the incomplete oxidation we are end up with the alcohol. The three thing: aerobic, anaerobic, and that in the absence of oxygen. If you remember, the 10th class topic. So maybe you know. If you don't know about this, just be noted, this reaction is important. It's a CO2. Okay, so this is important preparation for the like ethanol there. Next, properties. So about the property, the one of the famous property for what? Denaturation of alcohol. Okay, as the name suggests, we are going to disturb something, that we are going to denature something, or like we are going to form something that is not really fit for our health. Okay, yes, that one. So what is the denaturation of alcohol there? So actually this process is basically used for ethanol. Ethanol, as we're discussing about ethanol, definitely the main agenda is the ethanol now. So what is ethanol? C2H5 and OH. Do you know it? This is that alcohol which we are using for drinking purpose. C2H5. Okay. But the problem is what? Let's suppose, okay, we are doing experiment in a lab. Okay, the problem right now not in 11th 12th, but most of the time in graduation, post graduation, what is the problem? Student used to drink this. Right now this is not frequent, but in the old time it's really frequent there. So then fact, the companies be like, it's a very cheap product. And let's suppose that we are transferring alcohol from one place to another place. So in between there's some corrupt people as well. Maybe they use that ethanol in between the, you can say, way there. So what is the problem? Like how to solve the problem? So then government decide that let's add some poison into it. So how about the different kind of poison? There's a smell in alcohol. There's a smell in alcohol. So there's a three thing we are going to add. The first one is the methanol. Methanol. So out of all the alcohol, this is highly poisonous in nature. Okay, it's poisonous in nature. Poison first of all. Second of all, what we are adding, that is CuSO4, copper sulfate. Just because of this, there's a color. There's a little bit bluish color or like pinkish bluish color kind of thing. So this is responsible for the color. Okay, this one we are discussing. So first of all, you're using methanol plus CuSO4 color plus that pyridine. And this is the reason behind the smell, the foul smell. So there's a three thing: poison, methanol, color, CuSO4, and smell is this, sorry, pyridine. And now this alcohol is unfit for drinking. If you to consume this or accidentally maybe someone consumed this, so what is the reason, what is really happening? That you are facing the problem with your eyes. Okay, we are not able to see anything. It's that much poisonous. Yeah, you're right. Our professor used to say in our class that student always has a way, okay? Add some different reagent and then make this fit for drinking, chemistry student we are. Okay, so yeah, you can use, but it's no for everyone. Okay, better to stay away from the alcohol and all these things, right? So that's it. Addition of the methanol to make its poison. Pyridine is the foul smell. Copper sulfate gives the intense blue color to identify. Yes, very good, Shiva. Okay, so Shiva already know everything, right? So that's it. This is all for the denaturation. Let me just check any topic left or not. Done. Okay. So now answer a question. Okay, please. This is a question for you. Let me just write the question. So wake up if you are sleeping. So let me just write the question. Okay. You are having a cumin. Okay, this reaction consists all the concept till now which we already covered in the previous classes. So this is a cumin. I hope you know what is cumin. So first of all, we are going to follow the O2 and the second one is the water, some lipolysis. Okay, there is some P formation take place. And then we are using CHCl3 and there's a some NaOH formation take place. And this is this Q. Q is the major one. Okay, and there's a some R. R is the minor one. Okay then. And in this case, we are using NaOH and then pH CH2. Okay, let me just write clearly because we're going to use this, right? So it's a pH CH2 Br and plus NaOH. And then we are getting some S. Okay, so there's a some P, then Q, then R, and then S. S, P, Q is the major one, R is the minor one. Okay, you have to identify the correct statement. Okay, there's a some statement for you. So correct statement you have to identify. Let me just write correct statement. Okay, statement number one. R is steam volatile. Option number B, that Q is a dark color. Q give dark color with 1% aqueous FeCl solution. When with 1%, oh, just wait. Just start with your question. Till then, I have to finish the statement. Just try to identify what is this P, Q, R, and S. So it's with 1% FeCl3 solution. C is what? S is a S give, okay? So this is we are talking. S give. Yellow pipity. Yellow pipity with DNP. Let me just write 2,4 dinitro phenylhydrazine. And the option number D, S is a dark volatile. Sorry, dark violet color. Uh, give. S give dark color with FeCl 3 solution. So more than one statement can be correct. I'm repeating one more time. R is steam volatile. Q give dark color with FeCl. S give yellow PPT with T2,4 dinitrophenylhydrazine. And S give dark color with FeCl 3 solution. So you have to identify which one is the correct statement. And your time start now. It's a 2-minute question. Okay. Yes, Shiva. Cumin is a isopropyl benzene. Okay. Take your time and then answer the question. And it's advanced question. Okay. A, B, and D. Okay. You know what is this steam volatile want to explain to you? Hmm? I guess we discuss about this point where we are having a steam volatile or when in which case we are not having, right? If you remember. No, maybe you're right. Okay, I'm just kidding only. Single, correct, or multiple. More than one option, you know. I already highlight this is an advanced question, okay? So, more than one option may be correct. Wait, I have to submit my video here and answer. It's still adding the cumin, right? I hope it's better now. Yes, please answer the question. Last 1 minute left, okay. Good evening. I was writing a practical physics because I have practical exam on Monday. Then what you are going to do tomorrow, Venom? Are you that kind of student which just finishes their practical only for 1 day? Hmm? Means you are not a regular student, huh? Anyway, not an issue. Just watch the recording class, okay? Sorry, recorded class. Okay, Niharika. Hmm. I guess every boy is like this only. I know, I know. Done? Shall we discuss now? Okay, answer the question. What is P? What is P? Okay, Shiva. Okay, then. So let's just try to understand the question. Okay. So what is P? P is what? That is a phenol. Wait, I'm writing here that first of all, you are having a cumin. We discussed already about the mechanism in very much detail what is cumin and then how there's a aerial oxidation is there. So in this case, if you have to go with the aerial oxidation, the step number one, and then the step number two, we are following the hydrolysis step there. So what we are getting simply there, that is a phenol and plus one. Anyone? What is the side product? I told you already. What is the side product for this reaction? I told you this is the only reaction where the side product is much more important as compared to the phenol. Okay, Shiva. Acetone, very good. Acetone is the correct answer, okay? So plus in this case, we are getting what? Acetone as well, right? So anyway, acetone is not the issue here. So, okay, acetone is there. Okay. So in this case, the second step, what is the second step if you have to observe CHCl3? Okay, so what is this? What is the name for the reaction? We just discussed it's a Riemann-Tiemann reaction. Okay, so you can say it's a kind of Riemann-Tiemann reaction there. So wait, it's a P. Okay, let me just highlight. And if I'm using the CHCl3 and plus NaOH, it's a Riemann-Tiemann reaction. What we're getting? That is the condition number one. OH and a CHO. It's a Maser, okay? Maser product. And this is a minor product. I hope you already know. We already discussed this. In this case, there's an intramolecular hydrogen bonding. Remember? And hence, it's a Maser product. Although it's a ortho, but still it's a Maser product. And it is a minor product. So it's already written in a question if you are observing that Q is the Maser and R is the minor. So means what is my Q? Q is this. Okay, and this is my R. And now, as we discuss, if there is an intramolecular hydrogen bonding is present, so what is happening after the intramolecular hydrogen bonding? That molecule not have any connection or the weak connection between them, because inside the molecule automatically there is a hydrogen bonding. But in this case, in the minor case, what is happening, that yes, molecule connected with one another, so difficult to break the bond. It is difficult to break the bond, and hence boiling point is maximum. But on the other hand, in intramolecular hydrogen bonding, there's a no connection between the molecule. Easy to break the bond. Easy to break the bond means less boiling point or good volatile, you can say. Okay, so it's like orthonitrophenol. That is a ortho benzaldehyde kind of thing is also very stable. Sorry, reactive. So it's a steam volatile. Back now. What is written here? Q is a steam volatile. Is the Q is the correct answer? No way. Which one? Q is the major one. Q is having intramolecular hydrogen bonding. So which one is steam volatile? Okay? B is the correct answer. Okay. Okay. So I hope this point is clear. Like which one is the correct here? Like this is the correct. I'm sorry. Where's the steam volatile? S is a dark color. Okay, so R is not the steam volatile. It's not given an option. It means Q is steam volatile. Let me just write it. It is a steam volatile. So one option is not. Okay. Now, okay, what is Q? What is Q? Phenol, right? Means what I want to ask to you, that although it is connected with the CHO group now, but still this is a phenol. It means in this case, if I am adding the FeCl3 solution, definitely it is going to react with the FeCl. Definitely it is going to form a complex. As I already told you, the color can be changed if there is some substituent group connected with the phenol there, but still there is a complex formation take place, okay? As we discussed already like this. Okay, like complex formation still there. So this is the statement suggests that Q give a dark color with 1% FeCl3 solution. So is this correct? This is correct. Definitely this is correct. Okay, now the statement third said, or the C said, S give a yellow PPT with 2,4 dinitrophenol. Okay, although like I know that option C maybe you don't know. Okay, let me just explain to you what is this. If you are having a kind of aldehyde, okay, let's suppose you are having aldehyde, or not only aldehyde, even the ketone can be there. So both aldehyde and ketone, if let's suppose I'm having this kind of bonding, NH2 NH2. So what is happening there? That CO bond combine with N. So means what is happening? Wait. Let's suppose this is the bond like this, and then double bond bit with NH2. Okay, NH2 or R. Let's say some R like this. One more H I have to raise and like this. Okay. So yes, this is a kind of reaction you can say. So what is the question want to highlight with the statement number three? As is give some yellow PPT. So means we know one thing, that 2,4-dinitrophenylhydrazine. What is this 2,4-dinitrophenylhydrazine? You know hydrazine. I guess you already know this is hydrazine. NH2 NH2 kind of thing. Hydrazine molecule. Okay, it's connected with different group. So what is 2,4? It's a DNP. Maybe you know DNP test. 2,4-DNP. At least you are familiar with this 2,4-DNP. So in this case, that it's a NH2, NH2, and one more hydrogen. I'm going to use like this. And at second position there is a nitro group, and a fourth position there is a nitro group. This is our 2,4-DNP. Okay, so means this test is only positive. It means if you are having R, wait, I'm back. Let me just explain. This is some Q is going to convert into some S. So now we are going to check whether S has a aldehyde or not. Whether S has a aldehyde or not. Okay, so let's start with the Q. Let's just discuss about the Q part here. So Q is what? That are salicylaldehyde. Okay, this is Q. And now in this case, I'm using NaOH and plus that is a pH, CH2 and Br. Come on, what I'm going to do this if I'm observing some NaOH is there? Yes, please. What is the use of the NaOH here? Try to understand the organic chemistry. It's not that much easy for you. What is NaOH? It's a base. It's a base, everyone. So if NaOH is given, so search like in this Q molecule, where is the most acidic hydrogen present? And this is how we're using GOC in the organic chemistry. So now identify in this molecule, if you're observing something, that hydrogen may be present here, or hydrogen may be present here, or there's a like 1, 2, and 3, 4 hydrogen is there. So which hydrogen is much more acidic in nature? This thing you have to identify. And that's it. This is how we are going to use the NaOH part. Yes, please. Which hydrogen is more acidic? Okay, let's discuss about this. Look at this. If I'm removing this hydrogen, so what is happening there? The negative charge on a benzene. Benzene, no, it's not stable. Okay, so it means these hydrogens are not the acidic one. So let me just erase this and this. Now, what if I'm removing this hydrogen there? So come on, the carbon, what is that? It's not stable. So it's not stable there. The only one choice we are just left here, that this OH group. Okay. So it means the only main purpose of the NH is what? To extract this hydrogen from here. We are ready. And now, what is it? It's a pH, CH2 and Br. Isn't it a kind of substitution reaction if you're observing? Look at this. That oxygen has a negative charge, attack here, and bromine molecule leave out. Yes, it can be possible. So means what we are getting here, look at this. That this O blocked by the CH2 and the pH there, and this aldehyde will maintain there, and this is that S we are talking there. Now S is going to give the alcohol test positive or not. Okay, why this one? Because see that if I'm removing this hydrogen here, so this oxygen participate in a resonance. It's a stable carbocation, or sorry, it's a stable anion. It's a stable conjugate base. Remember in the acidity part we discussed about Dashika that we are going to abstract only that hydrogen which one is more acidic. Which one is more acidic? That after the removal of that hydrogen, the given conjugate base have to be the stable one, or stabilized by either resonance, or stable by either electron withdrawing group, or stable by the minus M group, or stable by the minus I or a minus H. Right, Dashika? So that's why we are abstracting only this hydrogen, the phenoxide hydrogen. It's a more acidic in nature. Okay, that's why GOC is important for understanding the reactions here. Okay, Dashika. Yes, please. What do you think about S? S give the FeCl3 test positive, yes or no? S give. FeCl3 test is for phenol. So S is going to give the FeCl3 test positive or not? No, okay. So why? Because OH is not free, if OH is not free. Then how? So in this case, you can say, in this case, FeCl3 test negative. And DNP test, 2,4-DNP test, as we discussed, that is a 2,4-DNP test is for aldehyde. So aldehyde is still free. So yes, it's positive. So now just back again toward the statements. So Q, we just discussed, right? S give the yellow PPT, yeah, definitely correct. S give the violet color complex with FeCl, no way. Because in S, OH is no longer present there. That's why D is also the incorrect option. Okay, is this point clear? That option B and option C is the correct answer for this given question. Okay then. Of course, geos is really very much important. Otherwise, we are not able to solve the problems. Okay. This is just a trailer. Just first, let's finish with the organic chemistry. Then we are going to conduct some classes for the question part only. Okay. Like just for understanding how to approach the organic chemistry question. Okay. I hope the phenol part or alkyl part is clear for everyone. In the next class, we are going to start with the esters. Okay. So, sorry, not ester, ether. I'm sorry. Okay. Steam volatile. I will repeat. Dashika, listen. Okay. See, if this is a molecule, okay, and let's suppose it is busy in intramolecular kind of bonding, right? So listen, my point, Dashika. What do you mean by the boiling of water? Okay. Yes, okay, CO won't have to be there. Okay, it's not positive for that COH group, but yeah, it's positive for the CO type of group. Means I want to explain to you. For example, if let's suppose this is a kind of this group there, so still, if let's suppose you are given not only this R, any kind of thing can be there like NH2, NH2. So still there is a reaction there. It means you can say N nitrogen and this kind of group has a friendship. Every time the reaction is going to be there. I'm sorry. Okay, so means that double bond will maintain and then NH2 group connected like this. Okay. Later we are going to discuss about that SIP basis imine in the amine chapter, okay? Lakshmi. So for this one, I hope it's enough. So keton, aldehyde both give this test positive, except the carboxylic acid. Carboxylic acid is not going to give this test positive, okay? Yes, please. So what we are discussing, if let's suppose I want to boil the water. So how it is possible, Dashika? So you'll be like, ma'am, we are going to heat the water, right? It's not like water start boiling without any heat, right? Are you getting? So, means what is the point, Dashika? That I want to boil something or I want to apply heat. So, there's a three-way total. First of all, that you can use steam. Okay, just steam, just like blower steam only for the heat purpose. This method number two, you can use the hot water bath. Okay, whatever you are having, just put in a hot water bath. So, hot water bath. Or the choice number three, that is a direct heating. So this is how you can apply the heat, either by steam, either by the hot water, either by the direct heating there. Okay, so in this case what is happening, let's just cover both the point. I'm raising this now. Okay, so this is ortho molecule, this is my ortho molecule, and this is my para molecule. Okay, so para be like, this is OH, it is participate in a hydrogen bonding with the different molecule like this. Same here, it is for the different one, and the CHO group still have to be there. Okay, like this. So in this case, one more molecule is there. Look at this. So what is the meaning of this intramolecular hydrogen bonding? That if you are observing this, the connection between the molecule. Okay, in this case, this connection is very weak. Because think about it. Let's suppose consider a typical example. Let's suppose we are living in a home. Okay, we are not having any good connection with the neighbor. Okay, so society is not going to matter if you are not having any connection with the neighbor. Okay, when the society is going to matter, then when you are having a good connection in your neighborhood and like this. So the para be like, I'm having very good connection, so you want to break the bond. So if you want to break the bond, you have to break this every bond, so you're requiring huge amount of heat. So steam is not enough for boiling. But in the ortho one, what is happening there? In case of ortho one, that the bond is weak, even steam can boil the molecule. So what is the meaning of the steam volatile? That steam, apply the steam and the thing start boiling. So this is the meaning steam volatile. Okay, Dishika. So is this point clear that why the ortho one when participate in intramolecular hydrogen bonding, it's written there that is a steam volatile. Yes, please, Dashika. Okay, and this is all for the class. I hope it's clear for everyone. Still any problem? Please ask now. Hmm. Okay then. So let's end the class then. Thank you so much for joining the class. Okay. But here is the para. No, 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 Dashika. Listen, that I'm giving you a kind of example. Ortho is steam volatile. Okay. And this is para is not volatile or non-volatile simply. Okay. So I'm explaining the steam volatile. Let me just back toward the question part again. What is this written here? Q is the major one, Q is the ortho one. Right? Q is the major one, Q is the ortho one, and it's written. Q is the like R is steam volatile. No, R is not steam volatile. Q is steam volatile. That's why A option is incorrect. Okay, Dashika. Are you getting now? When we will see the OH one always. No, no, no. It's not like for everyone. For example, if let's suppose this is OH, okay, and there's some bromine group connected. Now, hydrogen bonding is there? No. Are you getting? It was, yeah, 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 you're right. Now you're right, Rishika. Okay. Tomorrow is Sunday, right? No class for tomorrow. Class will be on Monday, okay? If I said tomorrow, so day after tomorrow, okay? Okay, Dashika, shall we go now? Okay, thank you then. Thanks for watching the class.